In this lab, we're going to perform some simple calorimetry, and what we're after in this lab is to come up with the amount of calories per gram of Cheetos. So we're going to take a Cheeto and we're going to essentially burn it, combust it. It's going to go under a chemical reaction. It's going to be exothermic. It's going to release heat, and that heat we're going to assume is going to heat all of the water, which means the water in our system is going to absorb all the energy released by the Cheeto exothermically. So that release of heat is going to make the temperature go up, and from a very simple understanding that a calorie is defined as the amount of energy needed to raise 1 gram of water 1 degree Celsius, we can come up with the energy indirectly that the Cheeto has. And I say indirectly because heat is going to be released and then absorbed by the water. So we have an endothermic process by the water, but it's initiated by the release of energy. That's why the whole process is exothermic. Our environment's going to get warmer. So if you look at my objectives, we're going to perform simple calorimetry. Now I say simple because we're going to have some issues in this lab, and I want to have these issues. Every single calorimetry lab has these issues, is that there is all the heat going to go from the water, or from the Cheeto to the water. And then the second objective is determine the calories per gram. You say, why per gram? Well, because if you notice, every Cheeto is going to be a different size, and finding the energy that's potentially stored in the chemical bonds of each Cheeto will be different because each Cheeto is not going to be the same. But if I take my Cheeto and I divide by the gram of the Cheeto, then I get the energy per gram. And notice we're trying to come up with calories per gram. And then number 3, you can see, is we're going to determine the accuracy of our results. We're going to look at the nutritional label, okay, and we're going to figure out exactly how many calories. Now, one important point, you notice they don't represent any joules here. They don't use any SI units. They use calories. Notice the big C. The big C means those are really kilocalories. And since only the fat's going to burn, we're going to do calories from fat, okay? And as we can see, there should be 90 calories per fat per serving. Now, what's the serving? The serving is 28 grams. So we're going to essentially find our calories using our joule formula of mass times the specific heat times the change in temperature of our water. And we're using the specific heat of calorie, we'll come up with calories, convert to kilocalories, because big C means kilocalories. And then we're going to divide by how many grams in this serving, which is 28 grams. And that'll give us calories per gram. So we're going to do those calculations. But we have to come up with energy first. So how are we going to do this? Well, let's talk about the procedure. In this procedure, what we're going to do is we're going to start with a 100 milliliters of water. So it's going to put that into this flask, this Florence flask, round bottom flask. Okay, now we know we have exactly 100 milliliters of water. I've measured that, and we know that the density of water is about 1, and we can just make that approximation. It's not going to be too bad. And we know that we have, well, if there's 1 gram per 1 milliliter, I know that I have how many grams of water here? Yes, 100 grams of water. So now I'm going to need an initial temperature, which we're going to write down in a second. But before we do so, the object that we're considering about testing here is this Cheeto. Now what I've done here is taken a paper clip and I've bent it in such a way that I've made a stand for it. So essentially I've taken a paper clip, bent it, made a little stand. What we're going to do is we're going to mass out this paper clip. Okay, I'm sorry, this Cheeto, because we want to know the mass of the Cheeto, because once we find how many calories of energy the water has absorbed, then we'll be in good place here to understand, to get calories per gram. So we're going to measure that out, then I'm going to impale it on this stand, then I'm going to put the stand inside this coffee can, which is part of my calorimeter. Very simple type of calorimeter. Now we have some issues here with heat, and again I want us to understand that's why this is set up that way. And then we're going to actually light and put this Cheeto on fire, and hopefully most of the energy will flow to the water, and we'll have a change in temperature of the water, and we'll move from there. So here is our simple calorimeter. Our first objective is to perform simple calorimetry. And this is our simple apparatus. And we do have some issues, as we always do in calorimetry, with the heat. Now notice if you look on the board here, we know that the energy that's stored in my Cheeto, okay, is due to the chemical bond structure. Okay, that's the potential energy, the chemical energy. And we're going to try to take that fat that's in the Cheeto that we talked about and burn it with oxygen. Oxygen's already air, so with some activation energy, this is going to burn. This is going to release energy. And the idea is we're going to put this Cheeto, after we mass it, and set it up on this stand. This little stand is nothing more than a paper clip bent it over. I'm going to stand it up on a stand, put it inside the can. I'm going to light the Cheeto. It's going to burn. And the energy released by the Cheeto upward should equal the energy absorbed. See, when we do calorimetry, it's a process by which we don't directly get the energy. I can't measure the energy of a Cheeto directly. But what I can do is have it release its energy, and by knowing a special property of water, which is remember, calorie is the amount of energy it takes to raise 1 gram of water 1 degree Celsius. If I know the temperature change and how many grams of water, I can figure this out. So the energy that's released by the Cheeto gets absorbed by the water. Why? Well, because of conservation of energy. Energy is neither created nor destroyed. Now, in truth, okay, this won't be perfect. We're making an assumption because there's probably going to be some heat loss. And that's where our error is going to be focused on. But assuming all the energy released by the Cheeto goes to the water in this exothermic process, because we're going to make the environment warmer. We're going to take an initial temperature and a final temperature of this 100 grams of water, which, by the way, I got by measuring out 100 milliliters of water. We know the density of water is about 1 gram per milliliter. So by 100 milliliters of water, I have 100 grams of water there. And I'm going to use the information about the water. I cannot really do the information about the Cheeto. Okay, why? Because I do not have a specific heat of the Cheeto. I don't have a change in temperature of the Cheeto. The Cheeto, gosh darn it, is going to burn. So information about the Cheeto is hard to grab. But I do know the water. What's the Q equal to? Q is equal to the mass of the water, specific heat of the water, and the change in temperature of the water. And that's going to give me the energy, okay, which we'll measure in calories and in joules for our data set, and eventually get to kilocalories, which is a big calories. So I'm using this of the water. Do not get lost when we do calorimetry, okay? We can't do the one object, but we do it indirectly. We get the energy indirectly by seeing what happens to the water. It's the mass of the water, the specific heat of the water, change in temperature of the water. Even though I might get a mass of this and I need to, that mass that I'm going to get is I'm going to use, once I get calories from my formula, once I get calories over here, and by the way, that's going to be kilocalories. So once I get kilocalories, I'm going to divide by the grams of the Cheeto. And that'll tell me, no matter what size Cheeto I'm working with, what the kilocalories are per gram, which, by the way, a kilocalorie, as we talked about, is a big calorie. Okay, so that's what we're after. It's very important you understand the process, that we're going to use the water to get us information about the Cheeto, assuming all the Cheeto does burn. But let's go mass out the Cheeto and get this started to get all our data. Okay, so here's my electric balance, and I'm going to hit read 0. Now it may not go to actual 0 because it goes at the 3 decimal places. Very precise instrument. It can pick up air currents. If I put my hand back and forth and make air currents, you can see I can make it go back and forth. So that's very, very precise instrument. Okay, so now what I'm going to do is I'm going to put a container on. Notice I just got the mass container. I'm going to hit read 0. We call this tearing out the container's weight. So I'm going to put this hit read 0, and basically the scale thinks that the container is part of the scale. I know it's -19. Let's try that again. Again, very, very sensitive piece of equipment if I move my hand too fast. Okay, there it is. So we're going to just go there. And I'm going to take my Cheeto. Again, there is air currents in here. but it does think that this is 0. I'm going to put my Cheeto in the container, and I want you to write down that mass. And we would say 1.670. Let's just make it that. Probably don't need such a precise instrument with the air currents in here. Okay, so we'll write that down. All right, as our value. That, of course, is in grams. Okay, so now what we're going to do is we're going to take the initial temperature of the water, 22.9, let's say. Okay, I'm going to put that back into the Florence flask where the water is. So what we're going to do now is we're going to take our Cheeto, we're going to pail him on a little stand. You see it stands up here. We're going to move the Florence flask off to the side a little bit. I'm going to put the Cheeto and his stand into the container. Okay, and what we're going to do now is we're going to light the Cheeto. Now once I light the Cheeto through the can, I might need to get myself a bigger opening here. Once I light the Cheeto through the can, alright, what I'm going to do is I'm going to lower the water down. We know the initial temperature of the water. We want to change in temperature. We know the specific heat of calorie is 1 calorie per gram per degree Celsius. We know the mass of the water is 100 grams. So we need to change in temperature to come up with calories. And then we'll convert to kcals and then divide by the grams of the Cheeto that actually burned. So I'm going to light this now. And when I light this, okay, we're going to witness pretty good exothermic reaction here. Okay, and then I'm going to lower this down. So hopefully I can light this Cheeto. Big enough flame. Got to look inside, see what I'm doing. And we'll know this thing is lit as it is now. Okay, and you can see the flame probably reaching the top of the can now. Now I'm going to lower my flask. And there we go. It's amazing how much energy is in a can. Let's get up close and personal, why not? And see what's going on here. And there's what's going on. You can see the soot. That soot is carbon. Yeah, so there's a chemical reaction occurring. The carbon it's in the what? That's in the stored as fat. All right, molecules in the Cheeto. Look at all that from a what? All of that from one Cheeto. Now we're assuming all the heat released by the burning of my Cheeto, you can see it's burning there, is being absorbed by my water, theoretically. Okay, and we're looking for the highest and warmest temperature of the water. Notice the black soot developing as a result of the incomplete combustion, meaning not all the carbon burned, okay, became CO2. There wasn't quite enough oxygen to make that happen. But clearly a nice chemical reaction. So now we're trying to find the warmest temperature of the water, the final temperature, because the water went up because it absorbed heat. And if you look, we're certain of the 40, 41, 42, 43, and I'm going to guess 43.6. It may not quite look that way because of the angle of the picture, but we're going to go at 43.6 degrees Celsius. Okay, last little piece here to finish out all the measurements we need to come up with our kcals per gram value, or calories per gram, big C, is we got to get after the remnants of our Cheeto. Okay, so what we're going to do is just pull up the flask here with the 100 grams of water that's been heated, and the can, which is part of my calorimeter, not a very good one, think about heat, and what we're going to come after here is just try to get what's left. And what we have here is our Cheeto. And you can see the Cheeto is nothing more than a piece of carbon. Okay, but not all of the Cheeto burned. Okay, only the fat is really combustible by oxygen. So what we're going to do in this lab is we're going to measure out the mass of this carcass of this Cheeto, And the difference between what we started with and what we ended with, it tells us how much Cheeto actually combusted, how much fat there was actually in this Cheeto. So let's go mass this out. So here's our scale back. We're going to put our container. We're going to hit re-0 just to make sure it thinks that that's the part of the container. And then I'm going to carefully take my Cheeto and I'm going to dump out the carbon and get our best reading. All right, my scale is jumping all over the place, but let's say it's 0.1. It is 0.1. 0.189. Let's just call it that. 1.89. 1.89. 2 cents of a scale in this wind. Okay, 0.189 we'll use. So the calculations at this point should be straightforward. Okay, understanding that we're dealing with the water's value. It's all about the water. And calorimetry, because we know how much energy it takes to raise 1 gram of water 1 degree Celsius, which is 1, we know how to get the calories. So we know the mass of the cheese curl we started, and after we burn. The difference of this would be the what? The mass of the cheese curl that actually burned, or the fat. We're going to need that at the end. We have the mass of my water. Well, actually, I have the volume of my water, which I know using density is 1 gram per milliliter. It's exactly 100.0 grams. Now I have 100.0 grams because of the measuring using the graduated cylinder. Now the initial temperature of the water we agreed was 22.9 degrees Celsius. After we burned the Cheeto, the water absorbed energy because it was an exothermic process. The environment's temperature increases, so it went to 43.6. That's where our last measurement there of the water. So my temperature change, of course, is the difference. To get the joules of heat, I take the mass of my water, specific heat of the water, change in temperature of the water. Why? Because the Q of the water, the energy absorbed by the water, equals the Q of the what? Cheeto that burned. We can't measure the Cheeto directly. Why? Look at it. We needed specific heat. It was changing during the process. We need its before and after temperature. Can't do it. So it's all about the H2O and calorimetry. That's why they call it calories. Any case, I want you to solve for joules using the 4.18 joules per gram per degree Celsius specific heat. Then I want you to solve for calories using the specific heat of 1. Okay. Convert. Now I have big C here. That should be little c. Okay, so regular calories is what you're going to get. Convert this number of calories to kilocalories. There's a conversion. We've worked with that, right? You can see how this course is building on itself. So take this little c here of calories, make it to kilocalories. Then from there, take your kcals, which is now the actual nutritional calorie, divide by the gram of what? Of Cheeto that actually burned. That's your fat. And that'll give you your calories per gram, and that's your experimental. Now to do the percent error, you're going to have to go to the nutritional label, which is on the other sheet, and you're going to have to calculate the kcals per gram of fat burn from the nutritional calorie and compare it. Okay? And that's what I'm asking you to do. So let's go to that quickly. So here's our nutritional label here. Notice they're going to give you the calories from fat are 90. Notice they're giving you 28 grams in their serving. So what good is calories if you don't know per serving, even though I'm writing on it? So this is 90 and this is per 28. So we're doing kcals per gram. Per means divide by. So I take this calorie, which is really a kilocalorie, right? So 90 kilocalories divide by 28. Show me the work is going to give me your nutritional value, or the known value, the accepted value, and do a percent error based on that. You should find your value to be under that. You should be having a negative percent error. Why? Why do you think? Why is our experimental value going to be under the known? And that's what I want to write in your conclusion. Very simple. Okay, we're not going to do this bottom part here. So your conclusion, you tell me what you got in terms of, let's go to the conclusion page to talk about that. So in your conclusion, you're going to tell me what you found. The first paragraph, I found that the kcals per gram of Cheeto was, and that was in your objectives. And then the last part is what the errors were. Well, the percent error was, that'll be in the first part. In the second part, now talk about your percent error. If it's high, tell me why. Okay, what are the errors that are built into this calorimetry, built into all calorimetry? Why was your value so negative? Okay, give me a good explanation, and that's your lab.